We are still with ellipse, and we have a long way to go in the topic for ellipse. What shall we do in this video? In this video, we shall lay down the standard equations for our ellipse. So whenever we speak about standard equations, that would be the case wherein we are showing the center of an ellipse. So by now, you must have some idea about how our standard equation will look like, but we shall begin with ellipse with center of the origin. So we shall have two cases. The one will be an ellipse wherein the principal axis is horizontal, and the other would be an ellipse whose principal axis is vertical. So Theorem 1.4, ellipse with center at the origin. Given an ellipse with center of the origin and whose major axis has a length of 2a and whose minor axis has a length of 2b, and the principal axis is horizontal, the standard equation is x squared over a squared plus y squared over b squared is equal to 1. Pay attention to this. 2a, 2b, and a squared and b squared. 2a, okay, this is a from the vertex to the center, that's a. So from one vertex to another, that would be 2a. So that's going to be the length of your major axis. The b there, the b will help you write the length of the minor axis. So the length of your minor axis is 2b. Okay, so one challenge for understanding the equation of an ellipse is to figure out if the principal axis or the major axis is horizontal or vertical. So pay attention to this. This is the relationship between a, b, and c. A squared minus b squared is equal to c squared. We shall need c to locate your focus. Now this is the relationship between a and b. A is greater than b. So that means a squared is greater than b squared. So when a squared, the bigger denominator appears under x, your principal axis is horizontal. What else? What else? So let us look into the coordinates of our important points in our ellipse. So this one is an ellipse whose principal axis is horizontal. So this is our center. So this is an ellipse whose center is at the origin. This is 2a. The length of that is 2a. So that means from here to there is a. That is why, that is the coordinates of your one vertex. And then from here to there, it's another a. But it's going to the left. So this is the coordinates of your other vertex. A would be important for locating the vertices of your ellipse. Now, how about B? Okay, so B is the number that would appear below the y squared there. So between the two, it's B or B squared, which is the smaller value. So we shall need B to locate the endpoints of your minor axis. Plus B, and this one minus B. So pay attention to the coordinates of your endpoints of the minor axis. The focus or the foci, how do we locate the foci? Well, we need first to locate, okay, let us go back to our equations. How do you get c squared? Or how do you get c? First, you obtain the difference. A squared minus b squared is equal to c squared. And then from there, you obtain the square root, and okay, c from the center would give you one focus to the right and to the left. Okay, how about when our principal axis is vertical? Okay, so that means our ellipse is standing up. That's vertical. When it's horizontal, our ellipse is lying down. That's the analogy or the metaphor that I can think about when it comes to the orientation of your principal axis. Between the two denominators, a squared is always going to be greater than b squared. So if it appears below y, below y. Y is the y-axis. That means our principal axis is vertical. From the center to the vertices, the distance would be a. Positive a, negative a. Okay, so we need them. We need those to locate the vertices. And the minor axis, or the endpoints of the minor axis, we shall need b. We shall need the value of b. And so, again, a squared minus b squared is equal to c squared. And along your principal axis, we shall locate the focus. So we add c there, and we subtract c. We subtract c from the center. Okay, so let us do some exercises. Oh, by the way, so this would be the vertices, or the important points along your ellipse when your ellipse has a principal axis that is vertical. A will help us locate the vertices. B will help us locate the endpoints of your minor axis. And C will help us locate the locations of your foci. When a squared appears below x squared, a squared is the larger quantity between the two denominators. Our principal axis is horizontal. Otherwise, when a squared appears below y squared, our axis is vertical. Okay. State the orientation of the principal axis. Is the principal axis of this ellipse vertical or horizontal? Okay, so let us look at the denominators. Okay, which is larger? So 9 is larger. This is your a squared. It appears under x, so our principal axis is horizontal. Which of the two is the larger denominator? This one. So this is a squared. It appears below y, so our principal axis is vertical. Let us look at this. Which is the larger denominator? Okay, so the larger denominator is 2. Okay, this is less than 2. So this is a squared. And it appears below x squared. That means our principal axis is horizontal. And finally, okay. Oh, by the way, what is the denominator of x squared? It's 1. Okay, so y squared over 25 plus x squared over 1. So what's the value of a squared? It's 25. The value of b squared is 1. So since a squared appears below y squared, our axis is vertical.